All right, so for today, we're going to cover certain topics. So I'm just going to show you, let me turn this volume up. I'm just going to show you from the course of study, the Alabama course of study, what we're going to look at. So first thing we're going to look at is number 16. We won't do every part of the standard that I show you, but we're doing bits and pieces of it until we get the whole thing covered. But today, we're going to define a function as a mapping from one set, called a domain, to another set called the range, that assigns to each element of the domain exactly one element of the range. I know you don't know what that means, but we'll break that down today when I get to the notes. We're going to relate the domain of a function to its graph. We're also going to determine whether a relation is a function. So those are the three things we're going to look at today, okay? So we'll start by just going through the notes. And all this is a review. I discussed this a little bit last year just to kind of give you some exposure about relations and functions and vertical line tests and discrete and continuous graphs and so forth, okay? All right, so let's just take a look at what a relation is. A relation is just a set of ordered pairs, guys. It's just that simple. And I'm going to list a set of ordered pairs so you can see what I'm talking about. Ordered pairs consist of an x and a y. This is called an ordered pair. So we're talking about an x coordinate. And we're also talking about a y coordinate. Okay. The x coordinate is how far you go left or right on a coordinate plane. That's your y axis. Let me color code these. The x coordinate is how far you go left or right. You can plot your x coordinate by going left or right from 0, which is your origin here in the middle. And the y coordinate is how far you go up or down from 0, or from that point from your x. Suppose you had 2, -3. Then you could go to the right 2 units, and down 1, 2, 3, and plot a point. That would be something like the point 2, -3 as an example. Okay, that's an ordered pair. But a relation is a set of ordered pairs. In other words, it's like more than one. All right, a relation can be shown different ways. A relationship can be shown in a table. Let me change the color back. A relation can be shown in a table, like an XY table, a chart. Okay. It can be shown in a mapping. Let me show you what a mapping looks like. So a mapping will have like an oval and another oval. The first oval will be your X and the second one will be your Y. Let me write this. I'm trying to write it where you can see everything, guys. I'm going to write the table a little smaller. I don't know what I had up here, but I'm just making up something. So that's the table. The mapping will look like this. You have one oval, which will be representing your X coordinates, and the second oval, which will represent your Y's. Excuse my ovals. I'm doing the best I can. All right, 1 might be mapped to 4. Just where this 1 represents your X and 4 represents your Y. Or 2 could be mapped to -5. And we usually don't, you can put the arrows or not, it doesn't matter. Sometimes you just draw a segment, but that's a mapping. Well, the elements in your domain or your X are mapped to your range, which is your Y. So the relation can be expressed as a table mapping. It can be expressed in a graph, and everybody knows what a graph looks like. a coordinate plane graph, guys, with an x-axis and y-axis. Or it can be expressed as an equation. So those are the 4 ways you can express a relation. All right. Now, the set of x values in your relation is called your domain. And you all may remember this from last year. And the set of y values is called your range. Domain range. Domain is x. Your range is the y values. All right, a relation with distinct points, distinct meaning you can tell what they are. It's called a discrete graph, okay? Or a discrete relation. A relation with connected lines or curves is called a continuous graph or a continuous relation. So let me show you what a discrete graph will look like. This is discrete. I'm just putting some points on here, okay? Doesn't have to all be on a line, but let me show you. Let me put another one. I'll put it in black. All right, this is discrete because I can tell that this is the point 1, 2. That's the ordered pair 1, 2. I can tell this is the ordered pair 2, 0. In other words, they look like little scattered points, but you can tell what they are. This is the ordered pair 0, 0, which is also known as your origin. And the green one is the ordered pair -1, -1. Okay, but in other words, a discrete graph, you can they're like little scattered points. You can tell what those scattered points or ordered pairs are. So that's called discrete. A continuous graph has lines and curves in it, guys. So let me give you an example of what a continuous graph looks like. And I will do it in, I don't know, we'll do it in this color. This is a continuous graph. You got curves in it. That's continuous. Could be a straight line. Yeah. Straight line is continuous either. You can't name all of the ordered pairs, so it's continuous. Okay. All right, so let's talk about what a function is. So I'm here, guys. A function is a relation in which each element of your domain, and the elements in your domain is known as x values, guys. So when each of your x's is paired with exactly one element in your range. Well, the elements in your range are known as your y's. So when each element or each of your x's is paired with exactly one y, in other words, x can only be paired with one and only one y. X can be paired with more than one y. I didn't say anything about y being paired with x, but x can only be paired with one y. So the key thing is to focus on your x's. So for instance, if I gave you, and you all write this down, I'm gonna write this as a set. All right, this is set notation, little squiggly lines. And let me change this color. Let me go back to red. 2, 4 as an ordered pair. 0, -1 as an ordered pair. 6, 5 as an ordered pair. 1, 3 as an ordered pair. Okay? And I put that in the set. Well, this is a function because look at each one of these x's. X here is only paired with 4. This x is only paired with, and we're focusing on the x's, guys, That x is only paired with -1. This x of 6 is only paired with 5. And this x of 1 is only paired with 3. So again, you're just focusing on your x's. I don't like the way I wrote that. Only focus on x. Just on x. And x can only be paired with 1y. That looks better. Now let me show you something that's not a function. Suppose you had 2 paired with 4, 0 paired with -1, 6 paired with 5, and then I put 2 with -3. Well, I'm gonna put 2 with 3. Well, only look at your x's. Here I can see the x of 2 is paired with a 4, and an x of 2 is also paired with a 3. But it says in order to be a function, x can only be paired with exactly 1y. That's it. Okay. But this x is 2. This 2 is paired with a 4, and 2. The x of 2 is paired with a 3. So that's not a function. Simply because when I say the x of 2 is cheating. You got the x of 2 is cheating with 4 and cheating with 3. Okay. X can't cheat. Doesn't matter what y does, but x can't cheat. So this may help you. X can't cheat, or that your x values do not repeat with a function. If your x values repeat, it's not a function. If you have an x value that doesn't repeat, none of your x's repeat, it is a function. Okay? Basically, ask yourself, is x being loyal? If x is being loyal, yes, it's a function. If you have an x not being loyal, it is not a function. Just try to remember it like that. Or just keep this in mind. Very, very important. X can't cheat or x can't repeat. Don't care about y. So let me just reiterate that, guys. If you have something like this, this is also going to be a function. I'm going to do the table instead of ordered pairs. All right, if you have something like 5, 3, -2, 3, 0, 3, it doesn't matter. This is still a function. Because you're only going to focus on the x's. And see, here are your x's, and none of those are repeating or cheating. 3's doing whatever it wants to do, but 3's a y, so it doesn't matter. Okay, but the x's can't cheat. All right, let's take a look at what do you do if you don't have like a set of ordered pairs or a table to tell whether the x's are repeating or not. You do what we call a vertical line test, and this is for a graph. If they give you a graph and they ask you whether or not, or if I give you a graph and ask you whether or not it's a function, you just do a vertical line test. Okay. It says in order to be a function, a vertical line cannot pass through more than one point in the relation, basically in the graph. If you do a vertical line test and vertical is straight up and down, that's vertical. If you drop a vertical line anywhere on the graph, and that vertical line that you drop or draw hits that graph in more than one location, it is not a function. Or if you draw it anywhere on the graph and it only hits it wherever you draw it in exactly one spot, however many times you choose to draw it, it is a function. So for instance, something like this, let's see. So I'm going to drop a vertical line. So here's the red line. That's the line. I'm saying that's my graph. Okay. If I want to see if this represents a function, I just drop a vertical line anywhere on that graph where it only hits the graph right there. Anywhere, it doesn't matter. And I'm going to do several of these. So you might have to erase. Okay, only hits it one spot. No matter where I drop that vertical line, my vertical line, which is green, is only going to hit the red line, which was the original line, in one spot. So it is a function. That would be an example of a function. Let me do another one, guys. This time I'm just going to make a discrete graph. Discrete. So what I just did was continuous, okay? Let me do a discrete graph with just some ordered pairs on it. Let me do, hold on, guys. Let me do some tick marks. All right. And I'm just going to put some ordered pairs on here. Okay, so those are my ordered pairs that I'm choosing to put. And again, this is a discrete graph because it's just scattered points, individual scattered points, which I can name. So I'm going to do my vertical line in purple. So basically, if you have a discrete graph, just drop the vertical line through the points that you see. Okay. There's only one blue dot in that one. Only one in that one. I see another blue dot right here. So if I draw a vertical line up or down, it's only one blue dot in that one. Only one blue dot in that one. And only one blue dot in that one. Now, let me show you what will happen. That's an example of a function. Let me go over here to something that's not a function. I don't like all those purple lines everywhere. You all get the gist of what I'm saying. These are functions. Ooh, that was good on my nerves. Okay, on the other box, I'm going to give you an example of what's not a function, guys. I just got to get rid of this purple. This is bothering me. All right, so let's look at what's not a function. If we get rid of this green too. All right. So to look at something that's not a function, first of all, I'm going to do a continuous graph. So a continuous graph has lines or curves. So I'm just going to do something like this. If that's my original graph and I drop a vertical line anywhere on it, then it crosses my graph here, my blue graph here and there. That's 2 points. That's not a function. Even if you had something like this, guys. Let me do the graph in purple. That's a continuous graph. It's not little scattered points. If I drop a vertical line, it still touches it and touches my red vertical line touches my purple graph in 2 spots. That's not a function. Now let me do one that's discrete. Discrete meaning points or ordered pairs I can actually name, or scattered points, distinct points, okay? And I'll do them in blue again. I'm just going to put some points on the graph. All right, and if I draw a vertical line, let me do it in black. Draw a vertical line through that point, all the way down, only 1 point. I'm good. Good there. Draw a vertical line there, only 1 point. Draw a vertical line through that blue point, only 1. But if I draw a vertical line here, there's 2 points in that vertical line, guys, that I drew. That makes it not a function because of these two right here. That's why it's not a function. You got 2 points in the same line. Okay, that won't be a function, guys. Okay, so let's take a look at some actual examples. So it says find a domain and range of each relation. Remember, domain is a set of all x values. Range is a set of all y's. Then it says determine if the relation is a function. Basically, x can't cheat. All right, so let's take a look at the domain. Okay, I'm going to just go ahead and put my x's. My x's are, and put it in set notation, little squiggly lines, -1, 0, 4, and 6. While I have my x's, while I'm focusing on my x's, I'm going to go ahead and put whether or not it's a function. Well, look at your x values. Are any of your x values cheating or repeating? Does -1 repeat as an x? Does 0 repeat as an x? 4 or 6 repeat as an x? No. All of your x's are being loyal. So if every x is being loyal, yes, it is a function. All x's are loyal. So yes, it is a function. Now I'm going to go ahead and get my range out of the way. My range is a set of all y values. So that would be -9, -5, 3, and -2. All right, you pause the video and try number 2. Okay, this is what you should have. All right, for domain, let me focus on my x's. 5, -3. Don't put 5 again. 5 is already in the set, so don't put it again. And 8. If you put it twice, I have to count it wrong because you've already stated that 5 is an x value. Why would you state it again? Okay, I didn't ask you to list all the numbers, even if they repeat. The domain is just the x values. If I know 5 is an x value, I don't need to know 5 is an x value twice, if that makes sense. Okay. All right, now let's focus on the function real quick. Look at your x values. Are any of your x's repeating? Yep. 5 is repeating. 5 is paired with 2, and 5 is paired with -6. So it's not a function. No, no, no. Okay, are all your x's loyal? And that would be a big no. Okay. 5 is doing the most, so we're going to say that's not a function. All right, now let's take a look at the range. The range is 2, just your y values, 4, -6, and 0. And that's all you do. All right, on 3, your domain is just whatever's in the x column. So in the x column, we have these. So you're going to list 7, 2, 0, and -4. And your range is just whatever's in the y column. -8, 3, -1, and I don't need to know that 3 is in there twice. I know that 3 is a y, so don't tell me 3 is a y twice. I already know 3 is a y value. All right, now, is it a function? So let's see. Let me go back and focus only on my x's, guys. Only on the x's. Are any of these x's repeating or cheating? No, they're not. So is every x being loyal? Yes. None of the x's repeat. All right, let's take a look at 4. I might be a tad bit sleepy. It's after midnight. I'm making a video. Okay, but let's just go and look at it. Domain. So if I make a mistake, guys, y'all look over me. I'm a little sleepy, I'll be honest. All right, your domain x is 10. Your range is, It's 15, 18, and 24. All right, your range, the set of the y's, all y's, is 0, 3, 7, and 11. And you just ask yourself, is it a function? I know. So I won't have to get up at 4 o'clock in the morning and do it. All right. Is it a function? Are any of your x values repeating? Okay. Are your x's being loyal? Yes. Every x is being loyal. There are no x's repeating. There are no x's cheating. We're good to go. Put a yes. All right. This relation is expressed as a mapping. That's when you got the ovals, okay? Okay, so you're going to focus on the x's and list my domain. Okay, in that oval, you have -4, you have -2, and you have 5. Now, be careful when you do the function, because I'm going to go ahead and look at it. Look at your x oval. Are any of those x's paired with more than one y? Well, 5 is a problem, because 5 decided to be with 7 and with 9. Okay. Are all your x's loyal? That is a no. 5 is with 7, and 5 is with 9. Keep in mind, I'm only focusing on the x's. I don't care what y does. Y can do what it wants to. X can't. All right, now as far as the range is concerned, just list all the values in the y oval: 0, 3, 7, and 9. All right, you pause the video and try 6, guys. All right, 6. What's in my x oval? That'd be 2, 8, 13, and 17. And I'm going to go ahead and talk about whether or not it's a function. Well, are any of these x values paired with more than one y? If one of those x values were paired with more than one y, you would see more than one arrow coming from each one of them. So in this case, every x is being loyal. This is a function. 2 isn't paired with anything else besides 7. 8 isn't paired with anything else besides 0. 13 isn't paired with anything else besides -4. And 17 isn't paired with anything else besides 7. So we're good to go on whether or not it's a function. Now, as far as the range, you just list the values in your y oval: -4, 0, and 7. And remember, when you list domain and range, please don't list a number twice. I don't need you to tell me that a number is in a set again. All right, so let's take a look at 7. 7, we're talking about domain, guys. And domain is a set of all x's, and you really can't see any, so I'm going to show you 2 ways you can do this. I can focus only on the x axis. So this is set. This dot right here has an x of 2. This dot right here has an x of -3. This dot right here also has an x of -3. And this dot right here has an x of 1, 2, 3, 4. You can just do it that way. All right. And when you get ready to list the range, focus on the y-axis. All right, so this dot has a y of 1. This dot has a y of -2. Now you got to go down to. This dot has a y of -1. And this dot has a y of -1, -2, -3, -4, -5. Now, if you don't like doing it like that, then no. So if you don't want to do it that way, this is what you have to do. You got to label your points. Did I leave one out? Yep, I did. This dot has an x of 0. And the order in which you put them in your domain doesn't matter. And this dot has a y of 1, 2, 3, 4. 4. Erase, please. Thank you. All right. But again, if you don't want to do it like that, then no. Let's focus on this die. That's a 0. 0 left, 0 right. And your y is up 1, 2, 3, 4. 0, 4. All right. You just label your points. This is an x of 2 and a y of negative 1. This one is an x of negative 3 and a y of positive 1. This one is an x of negative 3 and a y of negative 2. And this last one is an x of 1, 2, 3. An x of 3 and a y of negative 1, 2, 3, 4, 5. Negative 5. That comma is so big. Okay, let me make that smaller. Right, please. So then all you do is label your x's. So you should have an x of 2, an x of negative 3, an x of 4. Nope, I made a mistake somewhere. There's no x of, yes it is. Let me see, let me go back. Hold on guys, I gotta count. 1, 2, 3, 4. Oh, okay, caught myself. That's 4 negative 5. Erase, please. Sorry guys. 4 negative 5 is that point. All right, so you should have an x of 4. You should have an x of, I already got an x of negative 3. You should have an x of 0. And that should take care of all your x's. 2, negative 3. Now, I don't need to know that there are 2 of those negative 3's, guys. I just need to know negative 3 is an x value. There's your x of 4, and there's your x of 0. Okay, and then as far as the y's are concerned, here's your y of 1. Here's your y of negative 2. Here is a y of negative 1. There's a y of negative 5. And there's a y of 4 right there. You can just do it that way. Label the points if it's easier for you instead of doing it the way I originally did it, okay? Now, is it a function? Let me get rid of all this mess. To determine whether or not it's a function, let's look at a vertical line test. Okay, drop a vertical line. I'm sure you see it already, because with these discrete points, you can just look at it. Only one point in that line. Drop a vertical line. Only one there. Drop a vertical line. Only one there. Drop a vertical line. And I have 2. So this would definitely not be a function, because you have your x of negative 3 is paired with 2 y's. It's paired with a positive 1 and a negative 2, actually. All right, domain and range. If you'll notice, now I'm talking about domain and range of a continuous function, which I didn't go over that up here. We did maybe like domain. I didn't even talk about it there. Okay. All right, so we've only looked at domain of a discrete function. This was discrete, guys. I think we did this last year. Or we maybe talked about domain and range of a discrete function. But I don't think we did continuous function at all. So instead of doing 8, 9, and 10, I'm going to switch over and talk about continuous functions, domain and range of continuous functions. So I'm going to give you a set of notes on that. Then we'll come back and do 8, 9, and 10 and finish up here, okay? Okay, so we're going to look at this one. Domain and range of continuous functions. Domain, again, is a set of all x's. Range is a set of all y's. Continuous means your graph has lines or curves, guys. not little distinct scattered points. So this says for domain, in other words, to find your x values for your continuous graph, you're going to scan your pencil left to right along the x-axis, because the x-axis is the one that goes left and right. Okay? So you tell me what's the farthest to the left that your graph goes? What's the farthest to your right that your graph goes? And when you put your domain in range, more than likely it's going to be some range of values. Like it's going to be in between some range of values. But we'll talk about that. For range, which is your y values for these continuous graphs, you're going to scan your pencil from top to bottom or bottom to top. Along the y-axis. And the y-axis from top to bottom goes up and down. This is left. Ooh, bad L. Left to right. And this is top to bottom, okay? Now, more than likely, it's going to be some range because these things probably going to keep going. And if they don't keep going, they won't stop at one particular point. It'll span out across a section, okay? So let's take a look. So for domain, it's left to right. How far left and how far right? I'm going to do L and R because I'm being lazy. So if you take a look, how far left does your graph stretch? So my graph stretches to right here. It looks like right here. And that's to the left. But I'm going to show you something, guys. I don't want to cover up my arrow. I need that arrow to show you something. And it stretches to the right over here. Okay, so this is left to right. But the thing is, it has that arrow on it, so it doesn't actually stop right here. Because some people will say, oh, it stops right here at this point on the x-axis right there. No, it doesn't. That arrow means that that graph continues to stretch. So if it continues to stretch to the left, then it keeps on going along this x-axis. I can name any point on the x-axis. This is approaching negative infinity, guys. Like right here, I'm trying to tell you that some people say it stops right here on the x-axis. And let me do it in a different color. They'll look at that and say, oh, it stops right here on the x-axis because I'm extending the x-axis. And they will say, well, that looks like -1, -2, -3, -4, -5. Oh, it looks like -6. So it stops at -6 on the left side. No, it doesn't. It continues to keep on going. That's why you got that arrow. That's why you have this arrow right here, guys, because it keeps on going, okay? So if it keeps on going, it doesn't stop at any particular point on the x-axis. It doesn't stop right here. You can't label here. You can't label a point right here. It just continues to stretch to negative infinity. Okay, if this doesn't make any sense, pause the video and I'll come over, okay? But again, I'm going to try to go through this one more time. For domain on a continuous graph, you need to see how far left it stretches and how far right it stretches. So right now I'm just focusing on the left side. Erase, please. On the left side, it looks like it stops right here. That's where your arrow stops. But it's got an arrow, which means this line continues to stretch, okay? So it doesn't stop there. It keeps on going. So it stretches all the way out to negative infinity because it keeps on going to the left. Now it looks like it stops over here on the right. But be careful because there's an arrow. An arrow means it continues to stretch to the right. Stretching to the right, I better spell that correctly. Stretching to the right means it can stretch along, continue to stretch along this x-axis. But the x-axis will approach positive infinity. So the domain goes from negative infinity to positive infinity. Or, I'm going to show you something, guys. You can write it as all real numbers. And there's also one other way you can write this, okay? You can use this symbol. This symbol also means all real numbers. You just draw two lines and then the R shape. That means all real numbers as well. Or you can write it in interval notation. Totally up to you. I really like interval notation. It's easier to me. All right. So now, after you list your domain, in other words, how far does it stretch left or right? We got it stretches forever toward negative infinity and then toward positive infinity. So after you figure out how far it stretches left to right, now you need to look at range. We do top to bottom or bottom to top, guys. I like color coding. Top to bottom or bottom to top. So look at your graph, and I'm going to start on the bottom first. So the bottom of this graph hits right here, and only focus on the Y. Please do not focus on the X. Range is focused on the X-axis. Domain is focused on the X-axis, and range is focused on the Y-axis. Let me just put focus on X-axis. X-axis. Range, I want you to look at that Y-axis for me, okay? Because the Y-axis goes top to bottom. So the bottom of my V stops right here. At a Y, that's 0, -1, -2, at a Y of -2, guys. So let's see how, so that's the bottom. Okay, so, and that's on the Y. How far does this thing stretch up? I did bottom, top, huh? Go to the top. Well, it looks like the top stops right here. And that would be it, something like on this Y. I'm gonna color code. Let me do this in green. Look like it stops right here. Maybe at a Y value right here. But it has an arrow. And you're looking for the highest point. Okay. And maybe from top to bottom, I should do highest and lowest point. Probably so. Okay. I'm going to erase bottom and put lowest point. And the highest point looks like it's right here on the Y. But I don't think so because this arrow keeps on going, which means this thing continues to stretch up. So if I stretch my Y-axis up, if I keep drawing my Y-axis, this thing could have a Y value that was right there, but it actually keeps on going. So since it keeps going forever, and be careful with these arrows, guys, that means that it stretches forever. It's stretching forever going up. So stretching forever going up means that this thing doesn't stop right here on the Y. It approaches positive infinity on the Y. It doesn't stop right here, guys, because this thing keeps stretching forward. This right here keeps stretching up. It approaches positive infinity on the Y-axis. So your lowest point is at -2. You're going to put your lowest point first. And it's at -2. So put a bracket because it's actually at -2. And your highest point, it goes up to positive infinity. Okay, so this was the lowest. And this was the highest point. Again, it's on the Y-axis. And then here, for your domain, this is how far left does it stretch and how far right does it stretch. So remember, domain, how far left, how far right. range lowest to highest or highest to lowest. It doesn't matter. Just pick. I don't care what order you go in. But when you do your interval notation, please put the lowest and then highest. Like, put your lowest value first, okay? Always on interval notation. Let me show you another way you could have written the range on this one. You could have put your y values are greater than or equal to -2. Could have written it as an inequality. Because all my y's are greater than or equal to -2. If the lowest is at -2 and all the rest of them are greater than or equal to that, then you can just write it in inequality notation. That's called written notation, guys. This is written notation, where you write it with your variable. And why did I use a y? Because range is y. And this is interval notation. With interval notation, you don't have to put whether it's y or x. Okay? But since I'm talking, if I want to write it in written notation, you got to put y for range. If I were writing domain in written notation, I would put x. But your domain is all real numbers, so you're not going to list all the x's, okay? You just put all real numbers. All right, let's take a look at number 2. Number 2, look at how far it stretches. We're going left to right. So the graph stops right here to the left, and it stops right here to the right. That's as far as it stretches. Okay? So, let's see what that point is. -1, -2, -3. So it stops at -3 to the left. And it stops at -3, so use a bracket. And to the right, it stops at 1, 2, 3. Use a bracket because it actually stops there. So left to right, it's -3 to 3. Or you can put, in written notation, it looks like this. Your x values lie between -3 and 3. In other words, on the x-axis, I could shade between -3 and 3. That's the span of my range, my domain values. I could shade in between -3 and 3. Or you just write it in interval notation, okay? Your range is, I'm going to do lowest to highest. Instead of top to bottom. All right, so I'm going to color code. Let's do lowest. The lowest point on this circle is right here. And the highest point on this circle is right here. So that's -1, -2, -3. This is the lowest point. It's at -3, so use bracket. And the highest point is at 1, 2, 3, +3. Same thing as the domain. -3 to 3. Now, if you wrote this in written notation, I could go from, on the y-axis, my circle goes from -3 to 3 if I were to shade this in, okay? But it's a y. So put y. It's range, guys. So put y. I don't care if you write it in written notation or interval notation. You do what you want to. It's probably look better in green. I'm sorry. My OCD is kicking in. Okay, let's take a look at number 3. Number 3. It looks like the farthest to the left, it goes right here, but it has an arrow on it, which it means it continues to stretch toward negative infinity. And it looks like the farthest it stretches to the right is right here. But it has an arrow on it. If it has an arrow, guys, it continues to approach infinity, whether it's positive infinity or negative infinity. Okay? So to the left, it approaches negative infinity. To the right, it approaches positive infinity. Or we could just put all real numbers, okay? Now let's do lowest to highest. Okay, what is the lowest point on this graph? Well, it looks like this is the lowest point right here. Feeding to that Y. But it has an arrow on it, guys. And let me clean this up again a bit. Looks like that's the lowest point. But it has an arrow on it, which means it continues to go down. So if it doesn't stop right here at this Y value. It continues to go down toward negative infinity. And it looks like the highest point is right here. Okay, but it continues to go up. So the highest point is positive infinity. Some people will say, oh, that's a Y value of that, whatever that is. No, it's not. It's got an arrow on it. So it continues to go up. It doesn't stop right here, guys. It doesn't stop at that Y. And this point down here doesn't stop at this Y. Okay? Because they have arrows, they keep on going. So we're going to say that the Y value to the lowest point is negative infinity. And the highest point is also negative infinity. Okay. So I'm going to put the lowest point is negative infinity. The highest point is positive infinity. Or we can also put all real numbers for the range as well. Hi, Alicia. Okay, let's take a look at domain. Domain looks like it stretches right here, which would be maybe that point on the X, but it has an arrow on it, guys. So it continues to go forever. So this thing will just get wider and wider. And it would just stretch out. So the X, it could touch any point on the X axis if it kept stretching, okay? So because it has that arrow on it, it's not going to stop stretching right there. It won't stop stretching right here, okay? It's just going to keep on going. So it's going to stretch toward negative infinity. Because of that arrow, it approaches negative infinity, guys. And over here, it looks like it stops stretching right there to the right. This is to the left. And this will be to the right. It looks like it stops stretching right here, which is maybe an X right there, but it doesn't. It has the arrow, so it continues to stretch toward positive infinity. So the domain is negative infinity to positive infinity. Or we could again go with all real numbers, okay? All right, now I'm going to erase this and talk about lowest to highest value. So I'm going to focus on the y-axis, guys. It looks like the lowest point is right in here. I like using the same color, which is a y value of that, but it has the arrow on it, which means this thing continues to go down, which means it's approaching negative infinity, guys. Okay? So I'm just going to erase this. So because it's continuing to go down, it's approaching negative infinity going down. That's the lowest point. The highest point looks like it's right here. So that's at 1, 2, 3, 4. Again, that's at 1, 2, 3, 4. A y of 4. So I'm going to go with the lowest point is negative infinity. And the highest point is +4. And it's actually at +4, so put a bracket. Or I can write this such that y is less than or equal to 4. And your y values are less than or equal to 4. They're all these values from 4 on down. I hope this is making sense. If not, pause the video and let me know. Okay, let's take a look at 5. So if you take a look at 5, you all have to go home that quick. And if you take a look at 5, how far left does this thing stretch? Looks like it stops right there. And how far right? It stops right there. So I could shade between, let's see, that's -1, -1 to 1, 2, 3, 4, 5, -1 to 5. Or I could say -1 to 5 in interval notation, like that. And then the lowest point would be right here. That's a y of -1, -2, -3. That's the lowest. And the highest point would be right here. That's a y of 1, 2, 3. A y of 3. So -3 to 3. Yep. I want everybody to, I hope you understand what I'm talking about. The highest point is right here, which is at -3, +3 on the y, and also -3 on the y. So I can go -3 less than or equal to y less than or equal to +3, or -3 to 3 in interval notation. And I hope that makes sense, guys. If not, again, pause the video and let me know, okay? Let me erase this so everybody can see it clearly again. Here's the top part. That's the highest part. And that's at 1, 2, 3. That's at a y of 3. Here's the lowest point. And that's at a y of -1, -2, -3. Okay? So your y's kind of like go in between these two. From lowest to highest, okay? All right, let's take a look at 6. And if you take a look at number 6, how far left? It's got the arrow, so it approaches negative infinity. Okay. How far right? It approaches positive infinity because it has the arrow. So your domain is all real numbers, or you can put negative infinity to positive infinity again. And it's pretty much the same thing for domain. How far down does it go? Negative infinity. How far up does it go? Positive infinity. So it too is all real numbers, or negative infinity to positive infinity. The arrows pretty much mean it keeps stretching to an infinity, either positive or negative, depending on which way it's going. Okay, let's talk about the ones that have the bounce. All right, talking about the ones that have the bounce, guys. All right, so domain. I'm not gonna worry about the bounce right now. The bounce goes up and down, so that's gonna be you're gonna be concerned about the bounces on your range, because the up and down, a bounce goes up and down. That's your range. Right now I'm gonna focus on left to right. It has the arrow, so it's gonna approach negative infinity. To the right, it's gonna approach positive infinity. So that is all real numbers. Now, when your range comes into play, I need to look at my bounces, because this thing bounces. It's not like this one. This one didn't have a bounce. It just went up, it bounced down and back up, and it continued to go forward. Okay, it continued to stretch up. This, if I looked at it this way, I could go in this direction. I can say it went down, up, and continued to go straight back down. There was no continuous bounce. Okay, it was a bounce and then it gets stretched up and stretched down. Here, there is a continuous bounce. Bounce, 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 which tells me, even though I see these arrows, if this graph were larger, it would continue to bounce in the same fashion. Okay? If I had a larger graph, it would continue to bounce in the same fashion. I can see that from the pattern that's in the graph, okay? So you have bounces here. So you're going to look at how far up does your bounce go. So this is the top of the bounce. And that's at a Y of 2. And look at the bottom of the bounce. The lowest part is at a Y of -1. Let me do it in red. -1, -2, -3. So it's like your graph doesn't bounce any farther than, it only bounces between or from 2 to -3, or from -3 to 2. Okay, that's it. From here up to here, and then it'll bounce back down. Okay, or I can say from here down to here, and then it'll bounce back up. So your Y value bounces between -3 and 2, or I can put it in interval notation. So that's what we call a bounce graph, okay? Again, it's different from 6. 6 is not a bounce graph. It has a bounce in it, but it's not a continuous bounce. And you can tell that because you bounced here, but it didn't curve back like that. It continued to go straight up, okay? But here you can see the bounces on number 7. Let's take a look at 8. At 8, let's see how far left it goes. How far left would be right here, which is at -1. That's an x of -1. How far right? Looks like this is the farthest it goes, right, but it has an arrow. So it's approaching positive infinity. So I'm going to go -1 to positive infinity. Or I can say all my x's are greater than or equal to -1. Guys, I'm going to show you something real quick, because tomorrow I may give you something that looks like this. Now pay attention. Instead of a closed circle right here, I might put an open circle on that. That means that -1 is not included in your solution. So you would do -1 to positive infinity with a parentheses. Whenever you see an open circle, you're going to use parentheses for interval notation, or just put x greater than -1. But that's only if I give you, I think I'm thinking tomorrow I'm going to let you do more practice with continuous functions. Find a domain and range of continuous functions. But you may see these little open circles. That means don't put equal to if you write it in written notation. And don't put a bracket. Okay, if you see a little open circle on it. Just FYI. Okay? Okay, let's look at domain. Range. Let me erase this. So our range, how far down does it go where it continues to go down? It's got the arrow, that's negative infinity. I don't like it right into the side. It looks like to the right. Down is negative infinity. And how far up is also positive infinity. So I would say all real numbers. Or again, you could do negative infinity to positive infinity. This thing continues to stretch more and more up and more down. It gets wider and wider up and down. Okay, this is interesting. Okay, first of all, I don't like this graph. I'm gonna make this graph red because it's hard to see. I'm gonna do this one too. All right. This one is weird because you're thinking, how far left does this thing stretch and how far right does this thing stretch? Well, the line doesn't stretch at all. A vertical line doesn't stretch left and right. A vertical line only stretches up and down. So since it does not stretch left and right, you have to tell me the x value that it's located on. This line is located at an x of 2, and that's it. There is no stretch. There is no stretch on this one. Sorry. Erase. I can't get it to erase. Okay? No stretch on it, okay? So if there's no stretch, you just label where it is. It's at an x of 2. I got to use x because my domain is x. All right, look at the stretch for the y, the range. How far down does it go? Negative infinity. How far up does it go? Positive infinity, okay? So my range is all real numbers. Or I could go negative infinity to positive infinity, guys. Okay, let's look at 10. Okay, domain. My domain, it is stretching left. How far left is it stretching? Negative infinity. How far right is it stretching? Positive infinity. So again, that's all real numbers, or you could put negative infinity to positive infinity. The range is the problem because this line is horizontal. It's flat. It stretches left and right. Okay, a horizontal line does not stretch up and down. There is no stretch on the y. It's just y equal to wherever it is. It's at 1, -1, -2, -3, negative at a y of -4, guys. And that's all you do. There's no stretch on it. There's no stretch up and down. Okay? It's just at -4. Okay, that does it for domain and range of continuous graphs. I'm going to go back over here. And you're going to pause the video and see if you can try 8, 9, and 10. And then we'll see what we get, okay? All right, so for 8, this is what you should have gotten. To the left, it approaches negative infinity. To the right, it approaches positive infinity. So your domain is negative infinity to positive infinity. And most of you probably just put all real numbers. Your range is also the same thing. How far down does it go? Negative infinity. How far up does it go? Positive infinity. So I'm just going to go ahead and put all real numbers. Is this a function? Well, if I draw a vertical line, it only hits my red line, vertical line only hits the graph in one spot, no matter where I draw it. So, yes, this is a function. Okay. All right, how far left does this thing stretch? Well, this is the farthest to the left that it stretches, which is at -1, -2, -3, -4. And it looks like it continues to stretch this way, which is positive infinity. I could have also put an x greater than or equal to -4. Your range is how far down does it go? Looks like it goes down toward negative infinity. And it goes up toward positive infinity. So my range is all real numbers. Now, is this thing a function? Let's draw a vertical line. Looks like it. If I draw a vertical line, it looks like it only hits it here once. Only hits it here once. But if I draw a vertical line right here, it hits the graph right here and right there. My blue line hits the black graph in 2 spots. This would definitely be a no. I'm going to go ahead and look at this to the left, number 10. How far to the left? Well, that's going to be a -2, let me tell you. -1, -2. How far to the right? That's at 1, 2, 3, 4, 5. An x of 5. So it stretches between -2 and 5. You could have also written it in interval written notation. And the domain, I'm at the range. How far up does it go, guys? Right here, which is a y of 1, 2, 3, a y of 4. How far down does it go? Right here, which is a y of negative 2. So let's say it goes from negative 2 to, what did I say this was? 1, 2, 3, 4. 1, 2, 3, 4. Yeah. Or you could have written negative 2 to 4. Remember, write it low to high, okay? Is it a function? Definitely not. If you drop a vertical line anywhere on this graph, it's going to hit it in 2 spots. My purple line hits the oval here, and it hits the oval there. It's definitely not a function. Now, look, guys, I'm not going to do much with equations. You can take a graphing calculator and graph to see if these are going to be what the domain and range are. So domain is pretty much, can you put anything in here for x? And range is just what you got out. There are no restrictions on x for number 11. You can put in what you want. If I ask you to build a t-chart and put in some x values, you could put in whatever you wanted to. It doesn't matter. You put in whatever you wanted to, and you just get out any number. Your domain is all real numbers, and your range is all real numbers. But what I'm going to have you do is at some point, I'm going to give you a graphing calculator and let you graph these. Okay, so, but I kind of wanted to give you the gist of this. This is really an Algebra 2 standard. I'm just going to expose you to it, okay? So you would take a graphing calculator. I'm going to put in y equals to negative x squared plus 3. And I'll give you one if I have a chance to set this up tomorrow. Well, when I come in this morning, I'm about out of battery. When I come in, then I'll let you practice. But y equal to negative x and squared plus 3. This is what this graph will look like. As you can see, it stretches forever going down, left to right. It's going to get larger and larger and larger to the left and to the right. This thing is going to get wider and wider and wider if I were to keep extending this graph. So you can see my domain is continuing to the left and right. It gets to the left, it approaches more of negative infinity, and to the right, it approaches more of positive infinity. Okay, so your domain is all real numbers. But as far as, if I can get back to the origin, as far as the range goes, like the highest point on this graph is at, see, 1, 2, 3 is at 3. The highest point on this graph for the y is at 3, and then it continues to go down forever. So just looking at this, and I need to fix this. Your range will be anything from, what was it? Negative infinity to positive 3. Is that a function? Yes, it was a function. All right, but I will only give you the equations if I give you a graphing calculator. Again, this is an Algebra 2 standard. I may or may not have time to touch bases on it with you. If we have a day where we have some extra time, I'll show you how to use the graphing calculator and punch these equations in, and you can actually look at the graph, okay? Let's take a look at 12 real quick. 12, you can put anything in for y, you'll get anything out for x. That would be all real numbers, but I want to show you something on 13 and 14. On 13, your y is restricted to negative 7 because y is negative 7. So your range will just be negative 7. Your domain could be anything. On 14, your x's are restricted to negative 1. So your domain is just x equal to -1. But your range could be anything. It doesn't have a y. There is no y in this. So that would be all real numbers, guys. But again, I will give you a graphing calculator and let you check these, okay? Because we haven't even learned how to graph anything like quadratic. You will learn how to do it, but it'll be second semester. But I'm going to show you something like number 13 or 14 on this graph. I'm going to show you y equal to, let me hide this one. Y equal to -7. You see it's just that straight line going straight across right there. Your y, this thing stretches left and it stretches right. It stretches all the way to the left to negative infinity. Stretches all the way to the right to positive infinity. But it does not stretch up or down. So that's why you can just go with your, I went back to that one. Your x value, your y value, I'm on this one. Your y value is just y equal to -7. But for your domain, that thing stretch all the way to the left and all the way to the right. If I were to put in this one, x equal to -1. Let me hide this. You can see that it stretches all the way up, positive infinity, all the way down, negative infinity. But it has no stretch left or it has no stretch right. So since it has no stretch left or right, your domain is exactly at -1. That is it. But your range is what has stretch. Your range goes up and down. It's the all real numbers. And again, if I have more time, then we'll get the graphing calculators out. We'll try to do something like that before the Christmas break, okay? Not Christmas break, but Thanksgiving break. Those 2 days before we get out, at least one of them. Maybe just practice with the graphing calculator. All right, so guys, this was a lot of information. Let me see how long this has taken. Oh, we're not gonna finish all this in one day. All right, it's a lot. So what I'm gonna do, I'm gonna change the homework from instead of being due today, being due on Wednesday. So you'll watch this video in class Tuesday and Wednesday, and you'll do instead of homework, it'll be like classwork because this video is way too long.